Hello, beautiful people, and welcome. In this video, we are going to be graphing sine and cosine waves. Before we get started on any example, I wanted to go through the difference between a positive and a negative sine, a positive and a negative cosine. Now, if we're talking about a positive sine, that means your function is going to be an increasing function. And you will see a positive A value, which is your amplitude. And the characteristics of a sine wave is that it starts, ends, and has its middle on the midline. So if you have an increasing function, you're going to go up before you go down. So a positive sine wave will go up towards the maximum as part of the first quarter, the middle of the middle, as I call it. If your curve is negative or decreasing, you have a decreasing function, you'll see a negative A value, your amplitude. Now, the characteristics of a sine wave is that you still have your start, middle, and end on the midline, but because you are decreasing, you're first going to go down. So you're not going to go up because it's not an increasing, you're going to go down because it's a negative. For cosine, if you have a positive A value, the characteristics of a cosine is that, here's your midline, you're actually going to start and stop on the maximum. Your middles of the middles are going to be on the midline, but for a positive increasing cosine, the cosine curve is going to start on the maximum. If you have a negative amplitude, so a negative A value, a negative decreasing function, here's your midline. Because you are decreasing, you're actually going to start on your minimum values for a negative cosine. Okay, so let's go through this. Positive sine, go up from the midline. Negative sine, go down from the midline. Positive cosine, start at the max. Negative cosine, start at the minimum. And now we start with example number 1. We have y equals 3 times sine of, now they give you theta, so I will use theta, but I'm going to quickly change that to x. I personally don't like theta. I prefer my inputs to be x's. So without even doing anything else, I'm immediately going to change this to an x value. Step number 1, we need to factor out b. So what we have right now is x over 4 plus 2 pi thirds. This is what we currently have inside parentheses. So my trick is look at your b value, take its reciprocal, multiply by your c value, which is the original. So that means we have 1x, and I'm going to just take this b value in multiple steps. I have 1x, which means I have 1/4 x plus 2 pi thirds. So that means our b value is 1/4. So again, you have choices. You can either quickly do the reciprocal, multiply by the what you have, or you can set it up as your mini equation. And the mini equation is you're going to take this b value 1/4 times your h is equal to what you originally have, which is 2π3. So we're going to multiply both sides by the reciprocal. So if we take it, we flip it. This would be a 4/1. 4's go away. We're left with h is equal to 4 times 2 is 8π3. Again, when you have your h value like this, you're going to put it back into the correct format so we can then see what our transformational form is. So I'm going to rewrite this as y equals 3 times sine of 1/4 of x plus 8π3. Again, put this in a thinking bubble. This is now your transformational format with your true h value, your b. This is what we want. Step number 2, you're going to identify. Notice I don't have a lot of space here. You don't need a lot of space for this. We got your midline. You got your amplitude. And you got your start value, which is your phase shift. Your midline is your k value, your amplitude is your absolute value of a, and your start value is opposite of what you see h. So y is equal to, I do. Let's put that -2 into our equation. I almost forgot it. Hopefully you were yelling at me on the screen. So this is our k value. So we have a -2 for our midline. Your a is the absolute value of 3, which is 3. Then your amplitude. What I see is a positive 8π3. That means I have a negative 8π3 as my start value. Okay, that's step number 2. Step number 3, we're going to calculate our new period. Now these steps are the same for cosine and sine. New period, we're going to take the 2π divided by b formula, and our b value is 1/4. Now, take a look at how I wrote that with parentheses around the 1/4. Some of you are going to choose to use a calculator, and that's absolutely okay. When you do that, do not press the pi button. Instead, you're going to do 2 divided by, open, 1/4, close it, enter, and then whatever answer you get, just write pi after that. So we get 8, and then I did not type pi into my calculator, so this is now my new period. Step number 4, we're going to calculate the end value. End value is your start value at -π3 plus your new period at 8π, and that's going to be your end. Now notice here we do need to create some common denominators in order for us to be able to calculate this. 8π3 plus, and I'm going to multiply this top and bottom by 3 to create a denominator of 3. So we get 24π3. So we get 24 minus 8, or -8 plus 24, which is 16π3 as our end. Step number 5, we're going to calculate the distance between each x value. And again, distance is going to be your new period. And you're going to multiply that by 1/4, and it's always 1/4. This is going to be your distance. New period was 8 pi. So we're going to multiply that by 1/4, so 8 pi over 4, which is 2 pi. Now, step number 6, we want to create common denominators. And again, it's 3 values that we care about: our start, our end, and our distance. Our distance was 2 pi, our end was 16 pi thirds, and our start was negative 8 pi thirds. So 3, 3, not a 3. We got to convert our distance with a denominator of 3, which means our distance is going to be 6 pi thirds. And now we're ready to graph. I'm looking at my values. I have an 8 pi thirds and a 16 pi thirds, so I am going to need negatives on the x-axis. Negative 8 can be here. And if this is negative 8, I have 16 pi thirds somewhere here. Looking at step number 2, our midline is at negative 2. Here's our midline. Then our amplitude, we're going to go up 3, 1, 2, 3. Our maximum is then at 1. And our midline is at 1, 2, 3. So negative 2, negative 3, negative 4, negative 5. Oops, not max, min. And now we're going to use the distance of 6 pi thirds to calculate or add to find our x values. So if you're using a calculator, you got negative 8, only type in negative 8. Since we've created common denominators, denominator stays the same. I'm going to add 6 to it. That means I'm at 2, so negative 2 pi thirds here. I'm going to add another 6 to it. Why am I adding 6? Because 6 was our distance. Now I'm at 4. If this is 2, 4 is about here. Adding another 6, I'm at 10. Adding another 6, I'm at 16, where I should be on my end. This always should create 5 points: the start, the end, the middle, and your 2/4, your middles of the middles, and your other middle of the middle, which I call it that way. Okay, now what kind of function do we have? We have a positive sign function. Positive sign. So that means positive sign is going to start, end, and have its middle on the midline. So here's our start, here's our end, and here's our middle on the midline. And then because it is positive, we're going to go up towards the maximum value, increasing as we go up, since we have an increasing function. That means later we go down towards the minimum, but first we go up. Again, we are extending past our start and end values with arrows. Since we have a continuous function, these are not asymptotes, we are going to continue. And then we can always go back and clean this up a little bit. Always use pencil, not pen, because it will get messy sometimes. All right, and we have our curve. Let's go ahead and do some more. And as we do these, I'm going to try to work a little bit faster, so that way on the test you know that it's not going to take you 10-15 minutes to do one question. Let's do another example. Example 2. Y is equal to negative 2 plus 1/2 sine of 2 theta plus pi halves. Two things here that I personally have issue with. The theta, I don't like theta. I will be changing that to x. once you make the change, don't change back. Just make the change and stick to x if that's what you choose. Second thing I don't like is I don't like this -2 that they put out in front. This actually is your k value because we are adding, subtracting, technically subtracting to the function. This -2 belongs in the back in my opinion, but the computer does flip things around sometimes. So what I actually have is y equals 1/2 times sine of 2x plus pi halves, and this -2 I'm going to put in the back as my k value. Now I'm not going to put a thinking bubble or anything around this because I haven't factored out b yet, which is step number 1. Okay, so what do we have? We have 2x plus pi halves. So again, I'm going to pull out this b value. 2 times h is equal to pi halves. 2 times what is this pi halves? And we are always going to be multiplying by the reciprocal. So I see a 2. The reciprocal is 1/2. So that is what I'm going to be multiplying both sides by. Then we have pi fourths. After you factored that out, you're going to rewrite your equation. And that's the one we're going to put a thinking bubble around, so that way it stands out. Let's try not to forget my b value, -2. That's the one that I'm going to be looking at from here on out. Next, step number 2. Quick little table, midline, amplitude, start value, your phase shift. Midline is -2. Amplitude is 1/2. Start value is -pi fourths. Step number 3, new period. New period is 2 pi over b, which means 2 pi over b. This is my b value, which means my new period is at pi. Using the new period and the start value, I'm going to calculate the end value. So we want the new period plus our start value, which is -pi fourths. You can flip this out. It's the same thing. So if you want to do your start plus your new period, or if you want to do your new period plus your start, that's fine. Technically, we are subtracting. Common denominators are needed here. So I'm going to multiply top and bottom by 4. So we have 4 pi fourths plus a -pi fourths. So we have 3 pi fourths as our end. Step number 5, our distance. Distance is going to be your new period, multiplying always by 1/4. So we get pi times 1/4, which is pi fourths. And now we check for common denominators. Do I have space? Yes, I do have space. And again, for common denominators, we check our start, which was at -pi fourths, our end, which is at 3 pi fourths, and our distance, which is at pi fourths. Everything has common denominators, so I don't need to create anything. We are ready to graph. I'm looking at my values. I do have a little bit of a negative value here. So I will extend my x values into the negative direction. Our start value is at negative pi fourths. And we have 1, 2, 3, so about here-ish for 3 pi fourths. Going back to step number 2, my midline is at negative 2. I'm going to abbreviate that as ML, midline. Our amplitude is at 1/2. Okay, so here's an example of why I like doing my own graphs, and I always do this in pencil, is because my amplitude is 1/2. If my 2 is here, negative 2 is here, and I go up 1/2, I am going to have the tiniest wave here that is going to be very unable to read, illegible. So instead, I'm going to move my midline and say, here's 1, here's 2, and I'm going to extend this out even further. Again, we can do this because we're creating our own. Here's 1, negative. Here's 2, negative. So for my 1/2, here's my midline. I'll shift the midline there so it's not in the way. And I go up 1/2 for my amplitude. Here's my max at negative 1 1/2, or 3/2 to be more exact. And then we have our minimum value. So if that happens, definitely use your pencil, eraser, enlarge it, make it where we can see what you're doing. All right, what are we doing? We have a positive sine wave, so that means let's draw these out, otherwise it's going to get lost. Our start, our end, and our middle is going to be on the midline. Here's an issue with what I just did. I started graphing my points before I created my x values. So I technically don't know where my middle is, somewhere here, but I don't know where exactly that value is. So I'm going to go back and go to my distance. Distance is pi fourths. So we have 0, pi fourths, 2 pi fourths, 3 pi fourths. So my middle is going to be here. I have an increasing sine wave, so that means we're going to go up to our maximum first, and then later go down. Curve, arrow, curve, arrow. Now, everything is perfect except one thing here is that we need to simplify our fraction. So if we go back up here, this is fine. The negative pi fourths, 0 is 0. Pi fourths, but 2 pi fourths is incorrect. We need to simplify that to pi halves. If you do not simplify your fractions, it will be marked as incomplete. All right, let's go ahead and do a cosine. Example 3. Y is equal to negative 1 plus 2 cosine of 2 theta plus 5 pi fourths. Again, like the previous example, two things I don't like. I don't like theta. I prefer x. I also don't like that they give you adding, subtracting in the beginning. That belongs at the end for our case, so I'm going to be rewriting this. And putting that negative 1 in the back. This is not like solving an equation. This is just picking it up and putting it behind instead of having it in front. Step number 1, factor out b. again, we have a 2x plus 5 pi fourths. So that means 2 times what is equal to 5 pi fourths. Take your b value, which is 2, multiply by the reciprocal, which is 1/2. So that means we have 5 pi eighths. Again, don't do anything with that number. We're going to be rewriting our equation. Pulling out that 2 and rewriting that value as 5 pi eighths. And our k value was -1. Next, we have midline, amplitude, and start value, which is our phase shift. Midline is our k value at -1. Amplitude is the absolute value of our a value, which is 2. And our start value is opposite of what we see, which is a -5 pi eighths. Three is our new period. Same thing as cosine and sine. It's just 2 pi over b. Our b value was 2, so our new period is pi. Step number 4 is our end value. For our end value, we have our start. You can also start with your period, it's fine. Plus your period. Now I'm going to put a 1 underneath this, multiplying it 8 and 8 to create common denominators. So we have -5 pi eighths plus 8 pi eighths. So we have 8, technically 8 minus 5, which is 3. Positive 3 pi eighths is going to be our end value. Step number 5 is our distance. We're taking our new period, pi, multiplying it by 1/4. So our distance is pi fourths. Now, just because I'm kind of out of space here, I'm going to take a look, just looking at my start end. My start is -5 pi eighths. My end is 3 pi eighths. I don't have an 8 in my denominator here, so I'm going to multiply by 2 to create common denominators. So my distance can have the same denominator and have them match. And now we're ready to graph. I'm looking at my values and I am noticing my start has a -5 pi eighths, so I will be having negative x-axis. And I say that because sometimes you don't. Sometimes you don't need the negative x-axis. So we're at -5 pi eighths, so maybe around here-ish. And I'm looking at my end. My end is at 3 pi eighths. So it looks like we're having more in the negative direction. I like to do this first, the start and the end, because sometimes once you draw the midline, you use that as an x-axis and you start labeling the midline. You can't label the midline. The x-axis is the one that needs your x values, not the midline. So then we have here, you can choose to do your distance now if you'd like, because why not? Go ahead and if you want to use a calculator, you can. -5. Now we're going to just add your distance each time. So +2, we're at 3. Negative. Add your distance of 2, we're at -1. Add your distance of 2, we are at 1. And I'm noticing I have a very large distance here and a very short distance here. So I'm going to move my -3 pi eighths a little bit closer here. Then I'm going to shift this a little bit closer here as well. Which means my 3 pi eighth needs to be shifted out. Always use pencil. But this is here. We are human. This is not exact, but we also want to be as precise as we can. Our end is at 3 pi eighths. This should be not negative, this should be positive. And if we add another 2, we're at 3. Okay, we have our values. Our midline, let me take a look at step number 2. Midline is at -1. And midline, here, here, here. And then we have an amplitude of 2, so 1, 2. We have a maximum at 1. And a minimum of -2, -3. Okay. Next we have, actually we already did our distances. So we have a cosine. Cosine's positive. That means we start and end on the maximum values. That means our middle, find our middle, here is going to be on the minimum, and then our middles of the middles are going to be on the midline. Curve, bend down. So cosine cannot go past, well, sine cannot go past our maximum and our minimum values. So when you have this, you want to curve. Curve down. All right. Let's do one more example. Question number 4, and then we're done. For question number 4, we have y equals 3 times cosine. I'm going to immediately change it. So in your classwork, you'll see that we have in theta. I'm not writing that. I would like x plus 1. The reason I want to do this question is because it looks a little bit weird in that there are no parentheses. Let me actually show you exactly what it looks like. There's no parentheses here. You'll notice parentheses, 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 no parentheses. There actually are parentheses. You just don't see them. Okay? So the parentheses are around the x value, which has a b value. So what you end up not having is a phase shift, a horizontal shift you don't have. If you did have a horizontal shift, it would be in parentheses as a binomial. Because you don't have a horizontal shift, they do not provide you the parentheses. So very important that you put parentheses to help you understand that that plus 1 is a k value, not an h value. Let's start. Step 1, factor out b. Now, we have a 4x. If we factor out b, we have a 4x like this. There's no actual calculations because our h value is 0. We don't have an h value. So it is up to you if you want to rewrite it like this for our rewrite of the equation. Let's make this negative. No, let's keep it to the original. I wanted to change it, but then I'm reminding myself that this is a classwork assignment and I want to show you exactly what it is on the worksheet. So I will not be changing anything. Anyways, 3 cosine. Again, it is your choice if you want to rewrite it like this. It's just 0. There's nothing there. Or you want to keep it as something else. Now, I am noticing that I wrote 3. I don't know why I wrote 3. So let's change that to a 4. We'll change that in a little bit. Let's go ahead and move on. T-table, T-chart table for our midline, our amp, and our phase shift. Remember, a phase shift is opposite of what you see, start value. Okay, so our midline, we have y equals 1. Our amplitude, we got absolute value of 3, which is just 3. And phase shift, again, we don't have anything, so h is 0. So this is still our start. We are starting at 0, so we still proceed with the same things we do. New period, same thing that we've done many times now, 2 pi over b, 2 pi over, what's our b value? 4. So that means my period is pi halves. Step number 4 is our end value. Our end value is our start plus your period, and that's your end. Our start value was nothing, 0. Our period is pi halves, so we end at pi halves. Step number 5 is our distance. We take our period of pi halves and we multiply by 1/4. Remember, it's always 1/4. So we have pi, 4 times 2 is 8. This is our distance. Step number 6, we want to check for common denominators. For our start, which is 0, our end, which is pi halves, and our distance, which is pi eighths. So we don't have to do anything with 0 because it's 0. We're starting at the origin. But for our end value, we do want to multiply top and bottom by 4. So that way we can make sure that things add up to what it's supposed to add up. Let's go ahead and graph our last example. Looking at our start and end values, notice I don't have anything negative. So here's an example of where we do not need to have any negative x. So we're going to make that very short. Switching to pencil, always switch to pencil. We got 0 as our start. Our end is 4 pi eighths. We will change that back to simplified. Again, you may choose to do your distance now, which I'm going to choose. I'm at 1 pi eighth, 2 pi eighths, 3 pi eighths, 4 pi eighths. So again, you may choose to simplify your fractions now, or you can do that later. I'm going to choose to do that now. So we have pi halves and pi fourths. Midline, where was our midline? At +1. Amplitude at 3, so this is 1, 2, 3. 1, 2, 3. Here's our min value. Here's our max value. So 1, 2, 3, 4. -1, -2. Again, this is our start right here. So if you want to do a dotted line to show you where we start, and this is our end, it's up to you. Next, what kind of function do we have? We have a cosine. Is it positive or is it negative? It is a positive cosine. That means we start on our maximum. Start on the max, end on the max. That means our middle drops down to the not the midline, the minimum value. So, okay, maximum, because it is an increasing positive cosine. First, then the quarters, the middles of the middles, go to the midline. Curve, 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 not an asymptote, curve down, cannot go past the maximum values. All right, beautiful people, if you made it towards the end of this video with me, thank you very much. I appreciate you. Thank you for completing this worksheet, and I will see you next time. Bye.